Woo, we covered a lot of territory in just a few pages. You might have wondered why we started our geometry class with circles. But look at everything. We've learned 17 words in Metzi from your definitions page, 5 circle formulas, including the value of p. We always use units in cam, vets, etc. With measurements, units for distance, straight, round, or across, are in 1 dimension. Units are always squared for area, into, etc. In 2 dimensions, the units are cubed for volume, in 3, etc. In 3 dimensions, you may not realize it yet, but that understanding about dimensions is going to go a long way as we progress through geometry. All of math has a practical aspect, though, and geometry is no exception. Frankly, we couldn't even cook breakfast without measurements of some kind. Will that be 1 or 2? Okay, go to 2. A lot of math books try to give students a sense of how math is used by including page after page of word problems. How much sense does it make? Though, for Kelly to buy 562 rolls of paper towels at the store, even in the year 2020. That's why we opened this unit with a list of real problems from real people. We solved one already, and we'll get to the others later in this course. For now, I want to extend that garden problem to make it more real. Suppose our gardener just moved from Bangor, Maine, to work at a college in the United Kingdom, coming from America. He is familiar with English units pound, foot, gallon. Moving to England shouldn't pose a problem, right? Except for one sticky wicket. The United Kingdom has done a much better job of converting to metric than the United States, with a lot of the motivation coming from their prior membership in the European Union. Example, the gardener measured the circular planter box. This one's radius is 6 feet. He calculated the square feet of area he needs to cover with bark. 113.1 story. His employer wants him to cover the area at least 10 cm deep in bark. He has to purchase this by the truckload, and each lot of bark holds 1 cubic meter. Our gardener knows that one in 2.50 for chem. He also knows that 100 chem. 1m knows he can't mix units, feet, and meters without running into problems. What should he do? Let's help him work this out. Remember canceling fractions. Well, this time we're going to cancel words. Simply write the equal measurements as a fraction. Line up the words where they will cancel, then do the math on a calculator. Step 1. Convert 6 feet to meters, rounding off to the decimal places. Here's how it looks with the words canceled. Remember, that's 1. Step 2. Calculate the area. Square the radius before multiplying by 3.14. Step 12. We could also calculate the area and twofold from the area and photo. Oh, my goodness. Why is that calculation so long and ugly? It's because the area is in 2 dimensions. You see, if you have a measurement in total, you have to multiply it by the conversion factor 12 inches in a foot, twice to cancel both feet from the fraction. Remember, honey, that's part. It's the same with all the other conversion factors. Our final answer was off by a centimeter. Also, 100th place of meters represents a chem. That's because we used estimates for pi, and we rounded off in different stages of the calculations. As you learned from science, your answer will be accurate to 1 less digit than what you rounded to. We rounded to 2 decimal places, so our answer is accurate to 1 decimal place. Step 3. Calculate how many square meters a single cubic meter lot of bark will cover to a depth of 10 chem. First look at the cubic meter. Do you recognize the twofold? That's area. The times 1 and part must be depth. I think we're onto something here. A cubic meter will cover a square meter 1 deep. Now we can figure how many 10 chem deep square meters it can cover. That means the truckload of bark will cover 1 to a depth of 10 chem 10 times over. To put it another way, 1 load will cover 10 twofold to the required depth. Step 4. Calculate how many bags are required to cover 10.5 twofold. Oh dear. It looks like our gardener will have to buy 2 truckloads because 1 truckload will leave him a little short. That brings us to another important question. Why do math books include word problems? Anyway, memorizing formulas is one thing. With the invention of the internet, perhaps it's not even the main thing. You can always look that stuff up. Hey, Phil, what's important is knowing how to use those formulas in real-life situations. So, today and tomorrow, we're going to apply what we know. Be sure to read the solutions in the answer key because that may give you a different point of view on the problems. Example, a water tower holds a tank shaped like a sphere. The current tank has a radius of 10 feet. The town wants to double its volume. What should the radius of the new tank be? I'm confused. Wasn't that from yesterday's lesson? Yes. We're reviewing for the Unit 1 test in a couple days. We've learned everything required to solve difficult problems like this. We just need to look at it from the right point of view. Step 1. Find the volume of the old water tank. Step 2. What should the new volume be? Double the volume. Step 3. Substitute that into the formula for volume. Step 4. Solve for using algebra. Notice that the cube root of 30 gives us a one-dimensional fetch for the radius. Step 5. The solution of a word problem should always use words, but you may abbreviate radius of the new water tank. 12.64.